morning. So myself Dr. C. Vijay Kumar, Associate Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tirchanur. So today we discuss about the topic of non-conventional machining process. The non-conventional machining process, we have a different modules. We see first module, introduction of non-conventional machining process. Under the non-conventional machining process, what are the different types of non-conventional machining process available? Then what is meant by non-conventional machining process? Then how the non-conventional machining process differ from other conventional machining process? These are the some key areas we have discussed. We see one by one. So what is meant by non-conventional machining process or non-traditional machining process, as well as another name is unconventional machining process. So the unconventional machining process is a very special type of machining process because in this process there is no direct contact between tool and workpiece. If you take a conventional machining process, for example lathe or milling machine or grinding machine, whatever it may be, all conventional machining process, the tool and workpiece is a direct contact. Whether the process is started or ended is not at all a matter, but the tool and workpiece is direct contact. In unconventional machining process, there is no need of contact between the tool and workpiece. In unconventional machining process, a form of energy such as mechanical, electrical, chemical energy is used to remove the material from a given workpiece. This is called as an unconventional machining process. So what are the advantages? If you take any machining process, we have an advantage and disadvantage. In the same line, we discuss about what are the advantages of unconventional machining process. It has a good accuracy, it provides a good surface, complex shapes can be made easily, it has longer tool life, the rate of metal removal is high. Then disadvantages of unconventional machining process: the cost of process is high, it requires skilled operators, then its setup is very difficult. So need of non-traditional machining methods. So why we go for the non-traditional machining process or unconventional machining process? What is the reason behind that? The main reason for choosing non-traditional machining process are to machine high steel alloys. Suppose if you like to machining the high steel alloys, we go for non-traditional machining process is a best shoot. To generate desired complex surfaces and to achieve high surface finish and high accuracy. Due to non-traditional machining process, there is very less or no contact between electrode and material to be machined. High accurate, intricate and complex machinings can be achieved. In some alloys, surface roughness is a major issue if machined through conventional machining. Hence, non-traditional machining process such as laser beam machining, EDM, that is a electrical discharge machining process, then wire cut EDM, a wire cut electrical discharge machining process are preferred. Then what are the classification of unconventional machining process or non-traditional machining process are? We have majorly classified three types. The one is a mechanical, another one is a thermal, then third one is a chemical and electrochemical. So what are the process under the mechanical energy based non-traditional machining processes are? Ultrasonic machining process, water jet machining process, abrasive water jet machining process, etc. We are having a under the process of mechanical energy based. Then thermal energy based electrical discharge machining process, electron beam machining process, laser beam machining process, etc. we are using in under the thermal energy based. The chemical and electrochemical energy, chemical honing machining process, electrochemical machining process, these all are under the chemical and electrochemical energy based non-conventional machining process. Then what are the materials and applications? So we discussed different materials used in an unconventional machining process are titanium, stainless steel, high strength temperature resistant alloys, fiber reinforced composites, ceramics, refractoriness and other difficult to machining alloys have higher strength, hardness, toughness and other diverse material properties. Then applications where we using this non-conventional machining process, we see the machining complex shaped holes and cavities in molds and pieces, Various hard and brittle materials such as hard alloy and hardened steel are machinable. Processing fine deep holes, curved holes, deep grooves, narrow slits and thin slices among their things. Cutting and measuring instruments like cutting tools, sample plates and thread ring cages are machinable. Next we see about the first process of mechanical energy based, that is the ultrasonic machining process. What is the principle behind that working of this ultrasonic machining process? We see. So the ultrasonic machining process is a mechanical material removal process or an abrasive process. The abrasive particles are used to remove the unwanted surfaces or unwanted materials from the workpiece. These are mechanical material removal process or abrasive process used to create holes or cavity on hard or brittle workpiece by using shaped tools. The high frequency mechanical motion and an abrasive slurry. Ultrasonic machining process offers a solution to the expanding need for machining brittle materials such as single crystals, glasses and polycrystalline ceramics and increasing complex operations to provide intricate shapes and workpiece profiles. It is therefore used extensively in machining hard and brittle materials that are difficult to machine by traditional machining process. You see, this is the ultrasonic machining process equipment. The top one is the cone loading system. That is the abrasive particles loading system. Then under the right it's connected to horn. Then after that the tool is connected at a horn. The bottom one is the workpiece table. Then above the table we are fixing the workpiece. Then bump is used to pumping the abrasive slurry from the tank to that workplace. Once if you switch on, then the ultrasonic machining process, the process is started. The tool is vibrates. Once the tool is vibrate, the parallelly the abrasive particles are flow from top to bottom within the minimum gap. The vibrations is converted into as a mechanical motion, that is the material removed from the workpiece based upon the tool shape. It is called as the ultrasonic machining process. You see, this ultrasonic machining process, we are having a different elements in this process. First one is the high frequency generator. The high frequency generator used to generate the high frequency of vibrations. Next one, ultrasonic transducers. Third one, ultrasonic amplitude transformer and tool holder. And then final one is a tool. Once if you switch on the process, the high frequency will be generated from the high frequency generator. The high frequency generator is converted into vibratory motions with the help of ultrasonic transducer. Once the vibratory motion is started, automatically the abrasive particles then moving from top to bottom. At the time the abrasive slurry also passed at that place. The abrasive particles is hit the workpiece, then remove the unwanted materials based upon the tool shape. This is called as the ultrasonic machining process. The mechanics of material removal process. The material removal process is a type of manufacturing process in which the final product is obtained by removing excess material from the stock. The key parameters are used: velocity of gas, pressure, nozzle tip distance, material removal rate, substance integrity are studied and explained along with operations such as cutting, drilling, is adaptability, low capital and activity cost. These are also some important parameters. Suppose if you are using a mechanism of material removal, brittle fracture caused by impact of abrasive grains due to tool vibrating at high frequency. Then medium is abrasive slurry, then abrasives B4 silica, then aluminum oxide, diamond. The grid size is 100 to 800. The vibration frequency amplitude 15 to 30 kHz. Then tool material soft steel. Then gap is a 25 to 40 micrometer. Then critical parameters, frequency, amplitude, tool material, grid size, these are all the some important parameters. Based upon the parameters only, we remove the excess material from the workpiece. Then material application, metals and alloys, shape application, round and irregular shapes also possible to remove the workpiece based using this ultrasonic machining process. Limitation, very low material removal rate. As the frequency of material removal is very minimum, then material removal also very minimum. Then tool also parallelly wear. Then applications, ultrasonic machining process is most commonly used to machining a glass, ceramics, zirconia, precious stones and hardened steels. Ultrasonic machining process allows the cutting of complex and non-uniform shape with extremely high precision. Then advantages, disadvantages. So what are the advantages are there using the ultrasonic machining process? It is having a high precision, then low cost, high speed, it produces very little noise compared than other non-conventional machining process. It can be performed without any lubrication because we are using abrasive slurry, so no need of lubrication. It does not use chemicals in this process. So what are the limitations while using the ultrasonic machining process? It cannot be used on all types of materials because some materials are brittle and break easily when they are exposed to vibrations. The vibration have a high heating operation. Suppose if you apply the high force to the workpiece, then it easily broken out. So we are not we are not using this ultrasonic machining process with all materials. They cannot achieve same level of accuracy as machine like CNC milling or EDM. The disadvantage of ultrasonic machining are that the cutting tools need to be regularly replaced because they tend to wear out of over the time. So these are the ultrasonic machining process principle, working, advantages, disadvantages. Thank you for your passion listening. Keep learning, growing.